Hello, folks. Welcome to Rational Science, directly from Frankfurt, Germany, the only site on the internet that does physics. Everybody else does mathematics. They move concepts around. Anyways, today I think I'm going to be skipping over the comments and questions, okay, because I've got a full plate with the subject matter I'll be touching upon today. And in fact, I'll be skipping space as well. I'm going to postpone that till Wednesday. I was going to talk about space today. But again, I've got my plate full with what I've got here. So take that as a rain check, as false advertising on my part. And I'll touch upon that on Wednesday. Okay, so what am I going to be talking about today? I'm going to be talking about this fellow who made a video, 45-minute video, criticizing different aspects of my science series, okay? And he attacked each point. And I think it was good that he did that because, first of all, I was in the process of doing all these things. So it kind of, his criticism puts it into the right perspective. The other reason is that this fellow, he essentially represents what I would say at least 99% of the people out there believe science and the scientific method are about. Okay, so I think it comes in very handy what he did to come here and present rejoinders, rebuttals to what he had to say. Okay, so what's first of all different from our site to all the rest? Well, what we've been doing, what the mathematicians have been doing for the last 2,500 years at least, if not more, certainly more than that, is they simulated everything with particles, discrete particles. And they have no problem answering those visible things, things we can see and touch. The problem is when they apply those particles to the invisible world of Mother Nature, when they apply it to gravity, when they apply it to light, when they apply it to magnetism. That's where they run into trouble. You cannot explain a single one of those invisible, intangible phenomena with particles, with discrete particles. So this is just a quick illustration of the differences between what mathematical physics does and what the whole world does out there and what we do in this site. Okay, and here it is. Essentially, for the last 10,000 years, the rest of the world, everybody else does everything with discrete particles. And of course, with that, you cannot explain action at a distance. You cannot explain how one particle here affects another one over there. That's the whole problem, okay, or a big portion of the problem, okay? And what we do here, instead, we say that all atoms in the universe are physically interconnected. They're not interconnected like attached. The same thread that you see there weaves around and not only makes the atoms, but the interconnections. That's the proposal. That's the assumption with which we work here. Okay, so this shows you that we are a little different than everybody else. And of course, when you look at that, you say, well, yeah, with this, you can explain action at a distance because there is no real, true, genuine action at a distance. There is something between any two atoms, and it's something that we cannot see or touch. Okay, so that, I guess, puts it in the right perspective. Okay, so what did this fellow say? Well, the other day I started with analyzing what he said, and the first thing he mentioned was that he thought that science was alive and well, that for 2,500 years at least, we've made progress, and that especially we made progress in the last 200 years, he said. And the other day I criticized that. I'm saying that we have made not only no progress in 2,500 years, but in the last 200 years, more likely like 150 years, we've gone backwards. we stopped doing rationality. Before they tried to do rationality. After, you would say, end of the 19th century all the way to today, they abandoned rationality completely. All the explanations, all the physical interpretations are irrational. They're not wrong. They're not right. They're not wrong. They're irrational. They make no sense whatsoever. And it's not surprising that all the mathematicians always say, a lot of them say that, and people are not listening to them, but they say, we don't understand it. We cannot explain it. And people out there, the laymen, a lot of them say, sure you can. Sure you understand it, because otherwise we wouldn't have all this technology. And they don't realize that technology is not a proof, evidence, or anything related to theories, to the explanation the person gives for why or how something works. In other words, mechanisms and causes specifically. And so laymen usually are out of touch with that. They think that because you have a computer that verifies that quantum is correct, and if you have GPS, it proves that general relativity is correct. Absolutely not. GPS does not prove that time is a physical object that is warped, and computers don't prove that a particle can be at two places at once. So it's the theory, the explanation they give you, which is irrational, and which the mathematicians tell you in your face that they do not understand it, and they're absolutely right. They do not understand it. Okay, and so this fellow raised a second issue, following up on the one that I mentioned the other day, and that is that, you can criticize the scientific method, as he calls it. I call it the religious method or the mathematical method. But he says you can criticize it, but be sure you understand. Be sure you understand what science is attempting to achieve. That's going to be the argument that I'm going to be addressing tonight. Okay. So let's see what he had to say. Okay, listen carefully. Here, I'm going to put it on there. Okay. Pay attention. Here it goes. Hold on. The questions addressed in this rebuttal are, is there a rational way to do science? And what problems does science attempt to solve?
Science is a construct, so there's no inherent way to go about science. The universe doesn't say, this is how science must be done. Essentially, humans thought, okay, what is a good way of finding out more about the universe? And from that, they came up with the scientific method. If you disagree with the scientific method, then sure, feel free to challenge it, but make sure you actually understand what problems the scientific method is trying to solve.
Okay, so that's what he had to say about, that's the issue today. And yes, I guess you need to define what science is about if you're going to talk rationally about science. Okay, so you need to define the scope of science. What is science about, especially as it relates to physics? That's what we do here. Okay, so we're going to be talking about physics, science as it relates to physics. And yes, you need to define the scope. And the question is, yeah, you can criticize it, but like he said, you need to find out, what is science attempting to achieve? Okay, and so here's a little rundown of what the issues are. Okay, is there a rational way to do science? So it's not a question of what to do, if it's the right way or the wrong way. It's whether there's a rational way of doing science. That's the issue. This is not an issue of right or wrong, which are opinions. This is an issue of, is it rational or is it irrational? Okay, that's the question. And so he proposes the right approach. But you have to ask the right questions, okay, and find out what science is trying to achieve, and what is the scientific method attempting to achieve, and what is its purpose. I mean, and again, as it relates to physics. I mean, why are we doing science? Why are we doing physics? What is the purpose? What is our goal? What are we trying to learn or understand or whatever? Okay, so we need to put that in the right perspective. Okay, and I'm going to be arguing that for the last 2,500 years, we have never put it in the right perspective. In other words, people had the right perspective, but they never formulated it in an official way. Okay, I guess the closest to that maybe is Aristotle. Okay, that he kind of said this is what we're trying to achieve. Okay, but they forgot about that long ago. You know, they don't do that anymore, especially in the 17th century when they introduced experiments. They said you need to do an experiment as part of the scientific method. And that's when they screwed it up. And why did they screw it up? Because they want to do an experiment. They want to go to a lab. What do they call it now? Falsification, verification, any of those words? They want to go to the lab and they want to see and touch, run an experiment with that which is intangible and invisible. You can't see the mediator of magnetism, for example, or of gravity, and they want to go to the lab and do an experiment, what, to detect that which is intangible and invisible? So this is where the problem is. You cannot use experiments, which is what they've been doing for the last 400 years, to try to figure out, you know, what is out there in the invisible world of Mother Nature's that triggers, that causes, or is the mediator of light, gravity, magnetism, electricity, and so on. This is where the problem is. And so we need to zero in on what we're trying to achieve with science, meaning physics, right, in this case. And you can't use, in order to define the term science or the term physics, right, you can't rely on any of these. You can't rely on a show of hands, what we call democracy, okay? This is not a question of voting, because if everybody votes for the flat earth theory, that doesn't make it right. Mother Nature laughs at those people. Okay, so you can't say we're gonna just find out if we have 50% plus one and that's the winner. Now, aside from the fact that tomorrow that may change. Tomorrow maybe it drops to 50% minus one. Okay, someone changes his mind. So what are we gonna do? Just keep voting until we get it right? So no, you can't use democracy to resolve this issue. Then you can't rely on authority. You can't say, well, let's ask the professors, because they were brainwashed by the previous professors who were brainwashed by the previous professors. The only way they could have gotten a degree out there is if they parroted what the previous generation told them, because otherwise they wouldn't get a degree, first of all, and second, they wouldn't get a job or a career. And so, yeah, this is where the problem is. You can't rely on authority. And you can't rely on tradition. You can't say, well, this is the way we always did it, you know, since the days of the Greeks or whatever, Middle Ages. You can't do that because, just as an example, the 17th century so-called scientific revolution changed what existed until then, which was all these, you know, the Greek notion of how to do science. And the people in the 17th century decided to change that. They said, no, we're not going to do science like that anymore. Now we're going to introduce experiments, okay, specifically, and we're going to start testing everything that we do. All the assumptions, all the theories that we have, we're going to test them. And the way they did it, they said, let's go to the lab and find out, let's verify if it's true. You know, that's essentially what they were up to. And once again, yeah, there's nothing you can test, no experiment you can run on invisible, intangible entities. Okay, so if you have two magnets here, right? Okay, it's intangible, it's invisible, I can't see anything in there. You're not going to figure what's in there, in that region, by going to the lab. For that, you need to go to your desk, you know, dream a little, visualize, and see how Mother Nature could be doing that magic trick. Just like you would be doing if you saw a magician on stage, you know, cutting the lady in half or doing some kind of magic trick there. And you say, well, how did he do that? Well, one way of doing it is, you know, the first attempt is you try to visualize how the guy could have been doing it. Now, in the case of cutting the lady in half, you can reproduce it in the lab. What you cannot reproduce in the lab is whatever's in there, whatever's between these two magnets, okay, the two black round things there. that you're not going to discover in the lab. You're not going to discover, if you drop the pencil, okay, falls to the floor, gravity, right? You're not going to figure out what's here or here by running an experiment. The only way is to visualize and try to, simulate it with some kind of object that comes to your mind. So none of those, you can't use those to define physics or science, okay? And again, it's physics, science, the definition, right? Is not a matter of opinion, okay? You have to have a rational definition that you can defend. Okay, so again, the fact that we've been doing science in a given way for the last 400 years, that's tradition, maybe authority, maybe democracy, the fact that people voted for it. None of that counts. You got to defend your definition of science. Okay, so here we're going to try to define what science is. Okay, so one of the issues one of the ways to get to what science is, what physics is about, is by looking at what kind of questions do people ask? What do people want to know? What do they want to understand? What is it that they want anyone out there, so-called physicists, scientists, mathematical physicists, whatever, what do they want them to explain to them? Okay, and one good site is one where I write, and that's Quora. There's other sites, that do this question and answer thing, but Quora is one of them. And Quora, people go in there, laymen, whoever, and they ask questions. They say, look, can you answer this question for me? A lot of them are trivial and so on, but some of them get down to the nitty-gritty, to the basics. And they said, how does a magnet work? How does a magnet attract another? And how does gravity work? And so on. How does light work? And they ask these questions. Here you have the typical questions you'll find out there. Okay, not circumscribed to these, but these are questions you'll find in there for sure. In fact, you'll find these same questions asked in different ways because they just don't know how to ask them for someone to get someone to answer them. And here, what is light and what is light made of? And how do magnets repel away and attract each other? How do they work? What is electricity? How does gravity work? These are the types of questions people want to understand. They want you to explain these things to them. And when they talk about explanations, they receive a mathematical equation or a mathematical reference of some kind from mathematical physicists who go in there and try to answer some of these questions. They never receive a mechanism. What people want to understand is, again, a mechanism. Why does this pencil fall to the ground? What's pulling it or pushing it to the ground? That's what people want to understand. And they never get that kind of answer. They say, well, look, it falls at a rate of 9.8 meters per second square, and there's this field out there, and we've proven it, and this experiment's over here. They talk about a lot of nonsense. They never get to the issue that was asked. And so people ask it in different ways to see if maybe someone comes down to their level and explains it to them. Yeah, and you won't find it. And so the question here, the first question, or one of the first questions is there a difference between a description and an explanation, between how and why? And usually when you use the word how does gravity work? Well, that can be interpreted in two ways, as a description, as an explanation. And so some people give them a description thinking, well, I've answered the question, and the person's asking for an explanation. And a lot of people don't understand the difference. Okay, yeah, an explanation refers to causes, and a description does not address causes. That's the main point. But the point is here that we need to separate these two words, how and why, because it confuses a lot of people. When people say why, one of the answers you'll find out there, well, you keep asking why and why and why and why. And a lot of that refers to purpose and reason, which has nothing to do with physics. It has to do with philosophy. And so people think that, oh, you're just asking why, and you just want to know why is it like that. No, that's not the issue. The issue is when people ask why, they want to know causes and mechanisms. So all I can do is separate how from why. I'm going to be using here today, okay, how for descriptions, and I'm not going to use it for explanations. I'm going to use why for explanations dealing with causes and mechanisms, not with purposes or reasons, okay? In the context of physics, all why related to reasons and purpose all have the same answer, because God said so. That's the answer to that one, okay? So don't ask why in terms of what was the purpose, what was the reason, like if there was an intelligence out there that created some kind of, that set this in motion for some kind of purpose. We're separating that. So the why is going to refer to causes and mechanisms, and the how is going to refer to descriptions, okay? How, why, we're going to separate them. And here's some examples, okay? Okay, here's your how, description, okay? And again, it's I'm going to define it as a typically chronological listing of properties of or behaviors. That's what the how related to description deals with, okay? And there you have a couple examples. The red car crashed into the blue car at 50 miles per hour when the red car slid down the street, inclined to 30 degrees. And another one there. The victim died of respiratory failure at 3 o'clock, 2 hours after lunch. Those are descriptions. You have not explained causes, mechanisms, okay? You have not explained why. What are the whys? Well, they're explanations. What is an explanation? In the context of physics, okay? Revealing the causes that underlie mechanisms, okay? And so descriptions are not equal to explanations. A truck was towing the red car down the street with a chain, okay? So you're pulling on the truck, you're pulling on the car, and that's why the car was going in that direction and smashed against another car. You're giving a cause, okay? And in the case of the victim that died, the victim died when alkaloids entered her bloodstream and affected the transmission of nerve impulses that triggered respiratory failure. Okay, so one has to do with causes and mechanism. The other one is just a description of, the guy died at 3 o'clock, 2 hours after eating lunch. Okay, so we want to separate hows from whys, descriptions from explanations. And the problem we have today is that all that comes out of mathematical physics are descriptions packaged as if they were explanations, and people think they got an explanation, say, oh, I understood, okay, and he leaves. He never got an explanation of the mechanism. So we don't have mechanisms today. We don't have causes today. And mathematicians will tell you in your face, they cannot give you a cause, they cannot give you a mechanism, but people never hear that. They say, yeah, they know it because otherwise we wouldn't have technology. That's the answer that you're going to get. Okay, how about physics? Okay, here's a couple physics issues. Okay, here's a description versus explanation. The gravitational field of the sun, known as curved spacetime, is the centripetal force that causes the Earth's almost circular orbit. That's a description. So far, the person has not explained the cause, especially because they're using field, which is a concept. It's not a physical mechanism. Okay, field is not an entity that you can tie a horse to. Okay, and then you have that other case there. If the electrons in each of the magnets spin in the same direction, you have a strong magnetic field that produces attraction. That's a description. So far, we have no understanding of why the fact that electrons spinning pull on each other. How is it that two electrons which are spinning in the same direction pull on each other? We need to find out, the mechanism of how a magnet is attracted to another, and you can't do it by saying, oh, the electrons spin. See, this is the other way around. What they've done is they said, look, when a magnet attracts another, we notice, we measure, we detect that the electrons are spinning in the same direction. That's different than saying that the electrons spinning in the same direction cause or trigger a magnet to attract another. Those are two different things, okay? And that's what we're going to look at today. Anyways, here you see a why explanation, okay, for causes and mechanism. The centripetal force that keeps the Earth bound to the sun is mediated by cables. Now you might say, well, I don't believe in cables. I don't believe in chains. No problem. We don't care. We're talking about a mechanism. The person is saying that the sun is attached to the Earth by cables and vice versa. And so now we can explain what that centripetal force is. And then there you have for magnets, angels holding hands between two magnets and pulling causes attraction. And you might say, well, I don't believe in angels. Well, nobody cares. Nobody cares if you believe in angels. The issue here is mechanism. The person is explaining to you his theory of how angels holding hands pull two magnets together. Okay, we can understand that. What we cannot understand is a field doing that. Okay, fields are concepts. It's like saying love pulls two magnets together. No, it doesn't work that way. You can't use love to pull two magnets together. You can use angels, you can use ropes, you can use chains, whatever. You can use an elongated object between two magnets to explain attraction. You cannot use a concept such as force or field or energy to explain, why a magnet or how a magnet attracts another. That's the whole issue, okay? Okay, so what we're trying to answer again are the invisible stuff, right? Because the visible stuff we've already figured out. You see, again, I mentioned the other day, you have a cart, and the cart moved from A to B. And so you ask the boy, how did the cart move from A to B? And he said, oh, very simple. Very simple. I brought my horse, tied the cart to the horse, and I pulled it across. And so you look at that and you say, okay, I understood everything because you see all the objects. But in the case of magnetism, you have this invisible whatever, and you can't see it, you can't touch it, and so that's where people get stumped. And they say, mathematicians get stumped. They say, well, I don't see anything, I don't feel anything. So there's nothing there, and because there's nothing there, then it's done by magic. Again, angels have a better chance than mathematics to explain some of these phenomena. Okay. So here we begin with some of the testimonies, okay? And I brought a couple fellows, some of them you know. One fellow's name is Nick Lucid, and he has a program, he has a YouTube channel, the Science Asylum, so I brought him today to testify. And another fellow, another bigger celebrity, his name is Derek Muller. And he's going to be testifying today as well on my program, okay? So let's see what all these people have to say about magnetism, okay? How a magnet attracts another. Let's begin with one of them, okay? All these folks are on the internet, so you can find them there, okay? Here's the first one, okay? Give me a second here. Here it goes. Pay attention.
How do magnets work? A magnet is just something, normally metal, that has a particularly well-organized magnetic field. In most objects, the natural state of these tiny magnetic domains, as they're called, is essentially random, with their north poles pointing in different directions. The upshot being, in layman's terms, that they cancel each other out. But in a magnet, most or all of these magnetic domains line up in the same direction. And rather than cancelling each other out, the tiny magnetic fields combine to form a big, aligned magnetic field.
Okay, so we have this field, whatever that field is, and we have these domains. Is that what causes attraction between two magnets? We're going to use field and domains. I mean, you can say that within a magnet, like this little red one, round one there, that sticks to this one, you can say that the domains are aligned. Great, no problem. How does the alignment of that pull on this one? That's what you got to answer. And this fellow says, well, it's the field. Well, the field is a concept. Field is just a bunch of numbers. You can't use the word field to say that a magnet attracts another because of the field or because the domains are aligned. Okay, let's look at another one. Here's another fellow, and he tries to explain magnets again. They all claim to explain magnets, how a magnet attracts another, how a magnet works, or anything along those lines. Okay, and let's listen to this fellow. Okay, here he goes. Listen carefully.
If we truly want to know how a magnet works, we're going to have to zoom into the quantum realm. As we all know, electrons orbit around the nucleus of the atom on specific energy levels called electron shells. Within each electron shells exist subshells. Each subshell can hold up to 2 electrons which have different spins, which is nothing but a fancy term for the inherent angular momentum of an electron. Usually in a pair of electrons found in a subshell, one electron has a spin of up and the other electron has a spin of down. The spin of the electron, which is believed to create a small magnetic field, which combined with the other small magnetic fields from other electrons, can create one big magnetic field which is powerful enough to influence objects.
Okay, and again, we get the same old, same old. It's either the fields, or it's the virtual photons, or it's the electrons spinning in the same direction. Okay, so here we have 2 electrons. Okay, this one belongs to magnet A, this one belongs to magnet B. And they're spinning in the same direction. Okay, in this case, seen from above, it's counterclockwise. Okay, so how does that make this electron attract that electron, or this magnet, the one that this one belongs to, attract the magnet, this magnet here? How does it achieve that thing through the distance? So the fact that electrons spin does not give me a mechanism of how a magnet attracts another, okay? And neither does the field, which is a concept. Okay, here's another fellow, okay? You might want to listen to him. He probably knows exactly how it happens, okay? Give me a second here. Put him on, okay? Testifying.
In an atom, the rotation of nucleus and the revolution and rotation of electrons indicates the flow of small currents in them. This flow of current induces magnetic moments. The resultant of all the magnetic moments gives the net magnetic moment of the atom. Now, if all the magnetic moments induced in the material are in the same direction, then the material behaves like a magnet. But if all the magnetic moments induced in the material are in different directions, then they cancel out each other and their resultant becomes zero. In such cases, the material does not behave like a magnet. Atomic origin of magnetism in any magnetic material can be explained by taking into consideration the magnetic moments of the spinning and revolving electrons and also that of the spinning nucleus.
So what does the fact that the domains are aligned and the electrons are spinning, how does that produce attraction? Where's the mechanism? Again, these are descriptions presented as mechanisms. They're presenting the hows as whys, descriptions as explanations. That's the problem here. And people say, well, he explained it. No, he did not explain it. He described that 2 electrons spin and that the domains are aligned. That doesn't explain the causes. You want to explain how the cart went across, you got to say, well, I tied a rope to the cart and pulled on the cart. That everybody can understand that. But if you say, how did the cart cross the river or get close to the other cart on the other side of the river? And the person answers, well, the watermelons over here were spinning clockwise and the ones over here were also spinning clockwise. What kind of answer is that? How does that explain how one cart went to the other side of the river and hit the other cart? The fact that the watermelons on top of the carts were spinning clockwise or counterclockwise. What does one thing have to do with another? This is the issue, okay? And these people think they're giving you an explanation when they're not. They're giving you a description which is packaged, presented in the guise of explanations. Okay, here's another fellow. This is from UCLA, okay? University of California, Los Angeles, one of the top universities on the planet, okay? So, and this guy's a PhD. So here you're talking about major words, okay? Here he goes, okay? Give me a second here. Let me put him on.
One magnet either repels or attracts another, and nobody knows why. Except you. after watching today's video. One way to understand magnets is through magnetic domains. It was discovered that electrons had a property called spin. That is, the electron was spinning as it circled the nucleus. It's the alignment of these electrons' spins that results in the magnetic properties of iron. These atoms have an unusual double valence, in which their two valence electrons are paired with parallel spins.
In summary, a magnet is a collection of microscopic crystal domains that have their electron spins aligned. This is particularly prevalent in iron, nickel, and cobalt, in which there is a pair of valence electrons with their spins aligned.
Hotshot, huh? Knows everything. UCLA, PhD. And what do you say that the electrons spin? First of all, the electrons don't spin because what he did there, you know, throwing that little twirl on the electron, that's not what spin is. And all mathematicians will tell you that's not what spin is. Okay, remember, spin is a static concept. It's an orientation. But he says they're spinning, and he suggests that it's like a top, which is not spin at all in quantum. That's not the notion of spin in quantum. But that's how they present it. That's why they use the word spin, you know, and so he says it's spinning. Okay, we'll concede. So it's spinning. And how does the fact that this guy is spinning clockwise and this guy is spinning clockwise, both of them spinning clockwise or counterclockwise as seen from the top, right? How does this magnet attract this magnet? This electron belongs to magnet A, this electron belongs to magnet B. How does a magnet attract another because these two are spinning? Once again, how does a cart attract another because the watermelons in each cart are spinning clockwise or counterclockwise? Makes no sense whatsoever what these people are saying, but they're saying, oh, it spins. So what? It spins. What's the mechanism? So again, it's not an explanation. It's not a why. It's not a mechanism. What it is a description. There's twisting it around. They're saying what's really happening here is that every time a magnet attracts another, it turns out that when they measure, the fields are going in the same direction. They say, well, it's the electrons that are creating those fields, so they're all twirling in the same direction. That still doesn't explain the mechanism. The fact that the electrons are spinning in the same direction, right, does not explain the mechanism of attraction at a distance, from a distance. Okay, now, if each of the electrons were tied by, I don't know, by threads or ropes or chains or cables to the other electron, and this one spins, then yeah, we can imagine how it tugs on this one because there's an elongated object between them. Then we can understand attraction. But to say that the two balls just spin, one over here and the other one over there, and they're isolated because they're discrete particles, what have you said? You haven't explained the mechanism. Okay, here's my dear friend Nick Lucid, okay? And he's going to testify here for us, okay? Here he goes. This is his explanation of how a magnet works.
Any electron with a non-zero angular momentum will act like a tiny magnet. For each one that's in a clockwise orbital, there's another one that's in a counterclockwise orbital. This single electron has an inherent property called spin angular momentum. When you zoom back out to the atomic level, most of those electrons still pair up and cancel. Because like charges repel, they get as far from each other as possible and line up in the same direction. Getting the loner electrons to line up isn't enough. You also have to get nearby atoms to line up with each other, and then get enough regions of atoms to line up. We call those regions domains.
More of the same. What do we have? We have domains. What do we have? Electron spin. What do we have? Fields. There's also virtual photons, by the way. We haven't gotten to that, but you know, this is all nonsense. None of those are explanations for how a magnet attracts another. So all these people who are PhDs, okay, and they go out there and they tell you, oh, I'm going to tell you how a magnet works, how a magnet attracts something else. And what they give you is descriptions. They say, I explained it, didn't I? And no, they haven't. What they've done is they made a description and they presented it in the guise of an explanation. Okay, so here's another fellow, he does Minute Physics, okay, on YouTube, okay, and let's see what he has to say about
Magnetic objects are able to magically attract at long distances because they generate magnetic fields that extend invisibly out beyond the object. Magnetism is a fundamentally quantum property amplified to the size of everyday objects. In order for an everyday object to be magnetic, though, it has to have a unified kingdom of magnetic domains, each made up of bajillions of magnetic atoms which also need to be aligned with each other, each of which can only be magnetic in the first place if it has an approximately half-filled outer shell of electrons, so their intrinsic magnetic fields can align and not cancel each other out.
So, did you understand how a magnet attracts another? No, of course not. And here's the punchline to that. It comes from a fellow, his name is Derek Muller, and he decided to testify in this program as well. And here's his testimony. Okay, here goes.
Where do magnetic fields come from?
A magnetic field is just what an electric field becomes when an electrically charged object starts moving.
Particles with electric charge also happen to be tiny magnets.
If you want to know why they're tiny magnets, well, you may as well ask, why are particles charged in the first place? Or why do objects with mass and energy attract each other gravitationally? No one knows. We just know that's the way the universe works.
Never ask a mathematician why. Never. Because he says, well, all you're doing is just asking why, then you're going to ask another why, and why is this, why is that, why is the other thing? No, the first why is causes and mechanism. Whatever comes after that is not a why question related to physics. 99% of the time, what comes after that is a why related to purpose and reason. Why did God make it that way? Why is the speed of light 300,000 kilometers per second? That's an irrational question to present in physics, okay? That's assuming that, you're already assuming that there's an intelligence out there, God, for example, and he waved his magic wand and said, I'm going to make the speed of light little c, 300,000 kilometers per second. Why? Because he had a headache that day. That's the why for that. No, we don't care about that. We're talking about a mechanism. And these people are skipping the mechanism, say, well, you just keep asking why and why and why. No, we want to have just one why. We want a mechanism. You point to the mechanism, we understand it. You know, again, the fact that you say that two watermelons roll in the same direction, that doesn't explain the cause. So it's a proper question to ask why. How did one cart get attracted to another? Because the watermelons are spinning, you know, on top of the cart. So this is the issue. The issue is that the question of why, meaning causes, mechanisms, where you want an explanation, that's a rational question. Now, if the guy then later on says, but why does the electron spin? That's an irrational question. That's an irrational question if you're referring to purpose and reason, okay? Now, there could be a cause, a physical mechanism that triggers the electron to spin. That's something else. That's something you could answer within physics. But if you're just talking about purpose and reason, like why does it spin, who made it spin, who decided that it should spin, then you're talking about an irrational question. So you have to be careful with a why question. What are you addressing? Are you addressing physics, or you know, are you trying to prove you're God, that God, some intelligence out there, you know, set the world in motion in a certain way, and that's the reason, the purpose, that he's got a purpose for all this. That's separate. That's got nothing to do with physics. Okay, so the questions that you ask have to be related to physics in order to be rational. Okay, here are some of the responses you get in Quora, because you heard all these PhDs and they couldn't answer anything, and you get the same thing in Quora. And I only picked people who are professionals or who claim to be professionals, okay? I don't know them, so I can't say, but we're going to assume that they're telling the truth, and this is what they had to say, okay? And you have one fellow, he says, if two electrons spin in the same direction, it costs energy to keep them close to each other. And if you stop supplying the energy, they drift apart. So it's a question of energy, right? Opposite spin electrons have no problem sharing the same space. Okay, sharing the same space, you mean they superimpose? In the case of iron each atom has 4 unpaired electrons, which can accept opposite spin electrons into the same space with no constant energy supply. This makes them highly reactive to other materials with unpaired electrons. So far, he has not explained how one magnet attracts another. Okay, the fact that electrons are spinning, again, it's the watermelon spinning on top of the cart. And the other guy, he's a professor of physics. Okay, let's see what he has to say. Every electron is a magnetic dipole, okay, with an associated magnetic field. Again, we have the already saying that an electron is a magnet. It's got a field running around it, which is just a bunch of numbers. Okay, so a magnetic field is just values, strength. That's all it is. So we don't have a physical object. And he says in certain solids, and he mentions a couple there is not only an unpaired electron, there are also short-range forces between atoms that align the magnetic moments of those unpaired electrons to produce a fairly large region, a magnetic domain in which all moments point in roughly the same direction. Has he explained how a magnet attracts another? Has he explained the cause? Absolutely not. All they're saying, they're giving you a description and they're answering questions that people ask in Quora related to mechanisms. They want to have an explanation for how a magnet attracts another, and this is what you get. Here's another fellow also in Quora, okay? Again, all these are supposedly professional people, okay? Photons that are passed between bodies without the possibility of being observed are called what? Virtual photons. What is a virtual photon? It's a magical particle. It's a particle that appears at the end of a magic wand. Whenever the mathematician needs to explain something, he introduces the virtual photon, which means that immediately it disappears out of this universe. It appears only to make the equation come out right or his explanation come out right. That's what a virtual photon is. It says these virtual photons can form virtual photocurrents that try to minimize the energy squeezed into the field at any point of concentration. That is how magnets work. Yeah, no kidding. Any two magnets are exchanging virtual photocurrents, which tend to minimize the energy trapped in the local field. If placed with their poles north to south and the magnets are moved closer together, the energy in the field is minimized. If one magnet is turned 180 degrees and pushed together, the force required to push them together is delivered to the external field by making the virtual photocurrents more intense. Each virtual photon represents a unit of energy. Again, this is all nonsense. This is poppycock. Hasn't explained absolutely anything. Talking about virtual photons, which are magical particles that appear again at the whim of the mathematicians, and then talking about energy and fields, and those are all abstract concepts. We need to find out what physical object brings two magnets together. That's what is the mechanism. And if you say there's nothing there because you can't see or touch it, you are in effect doing black magic. You're saying that this one attracts that one by way of concepts, fields, particles that are not particles, forces which are not things, energy, concept. How does this one attract that one? So you need to explain the mechanism. And of course, they cannot explain that mechanism. That's the problem. Why? Because they can't see or touch the mediators. And because they can't see or touch them, they say there's nothing there. Well, then are you going to do action at a distance with magic? If there's nothing there, you're doing it with magic. That's what you're saying. The universe works with magic. Okay, this is what you're defaulting to when you don't put an object in there. Okay. Okay, here's another fellow, Quora, okay, says spin angular momentum is an inbuilt property of electrons. Again, all that spin stuff, right? This spin, it makes me spin. The spin can take only two values, +1 and -1. And if the electron is spin up, it produces a magnetic field in a particular direction, and a spin down electron produces it the other way. Great. So the fact that they're spinning, one goes away and the other one comes towards. Why? Do we know why? All he did was describe and say, whenever it spins, we notice that they come together. That's all he's saying. He's not explaining why the spinning causes one magnet to attract another. And another fellow says here, sometimes people explain the effect of the magnetic field in terms of virtual photons. This is frankly not very helpful. So this guy is debunking what the other guy said. He said, no, he's wrong. We don't do it with virtual photons. Okay, so what do you do it with? It is much better to explain the attraction or repulsion between magnets as due to the magnetic field. Okay, now you introduce the field, the concept, rather than in terms of emission of particles. Okay, excitations of the electromagnetic field are called photons, but these are nothing like classical particles. They are what? Excitations. In other words, they're verbs. He's saying that excitations is what's going to produce attraction. So they're talking about fields, which are concepts, bunch of numbers, values. And then he says it's excited, it waves, it vibrates. And because it vibrates somehow, whatever the mechanism is, it produces the attraction between two magnets. And please don't use virtual photons or photons at all. No, we're going to use fields, concepts. Yeah, again, what these people are doing is magic, because they're trying to explain this with magic. And they're saying with concepts, and that is magic. It reduces to black magic. You're saying that a magnet attracts another because of love, or because intelligence, or because of data that you collected. How does that explain the mechanism? And that's where all these people fail. But it's interesting, a couple of the other answers that people gave in Quora, and these are very interesting because they show you where they really stand, okay? These guys say it better. First guy says, the answer is virtual photons. Being a mathematical convenience, I would call them questionable existence rather than invisible. Okay, so this fellow doesn't believe in virtual photons because he says it's just a mathematical convenience. What does the other fellow say? He says, it's pretty clear from the answers given here, and there were like 40 answers at least in one of these questions, that the actual answer is that no one knows how magnets work. I had a career which involved the design of transformers which completely rely on magnetism for their operation, and I certainly do not know how they work. One guy said it truthfully, okay? Yeah, they don't know how magnets work. When you go to the university, they don't teach you how magnets work because the authorities, the people who teach, never learned or never figured it out. And all they do is parrot what their previous teachers told them, which parroted what the previous teacher told them. So it's just a succession of ignoramuses who pass this non-knowledge, this notion that electrons spin, or that fields mediate attraction, or that virtual photons mediate attraction. All these people, all they do is just pass on from one generation to the other, and they have no mechanism. So this fellow is right. No one knows how they work. Okay, so let's get it right. These people have no explanation. Not a single person out there who has a video on YouTube, not a single person who answers in Quora can tell you how a magnet attracts another. And they put how a magnet works, how a magnet attracts another. It's nonsense. They cannot tell you, okay? And the first thing you have to realize that Faraday and Maxwell, especially Faraday, who studied magnets quite a bit, he said there's got to be a physical object in there, in that place we call field. Remember, he's the guy who invented the word field, okay? And he said, after studying magnets for half his life, he said, there's got to be something in that region we call field. There's something in motion in there. Okay, here are the testimonies of these two individuals. In the case of Faraday, he says, I cannot conceive curved lines of force without the conditions of a physical existence in that intermediate space. And what did Maxwell say? He says, field, the space in the neighborhood of the electric and magnetic bodies. In that space, there is matter in motion. So both of these people, both of these individuals, they said, there's something there. Those lines of force are not abstract. And the so-called field is not an abstraction. There's matter in motion, an exotic type of matter, obviously, but it's matter in motion. So a field is something that is moving. In other words, inside the field there is something that is moving. The field may be static. If you throw iron filings on top of a magnet. They line up and they form the typical patterns, okay, that you see maybe on a piece of paper or whatever. And so you say, well, there's nothing moving anymore. Everything just there. All the iron filings are glued to the magnet. So in that sense, there's nothing moving. But what these two people are saying, they're telling you, okay, is that even though the iron filings are not moving, the magnetic field is something that is made out of something that is in motion. There's some exotic matter in motion in what we call a magnetic field. That's the issue. There's something there. You can't see it, you can't touch it, because something is not that which you can see or touch. Something is that which has shape. And in the case of magnetism, light, and gravity, you can't see or touch the mediators. So see and touch are the wrong criteria to define the word object, the word thing. Okay, so this is how we do it in science, at least here. Okay, we explain a mechanism. And for that, first we have to show you what is inside that field that both Faraday and Maxwell said there is matter, there's something moving in there. In that so-called field, the iron filings stand still, but the field is moving. Something is moving in the field. Okay, and the fact that I showed in the past that underwater magnets attract one iron filing at a time show you that there is something in motion in that so-called region we call field. Okay, and so this is what we propose. Okay, we are saying that field is made out of all these threads that are sweeping around, they're swinging around atoms. Okay, that's what we call a field. A magnetic field is comprised of swinging threads, and electricity consists of spinning merged electron shells. We have rows of electron shells, typically at the molecular level, and those form the so-called domains of a magnet. When they're aligned, the threads that are swinging around, they sweep in the same direction, and now you have what is known as a field, a magnetic field. Okay, so that's what we're proposing. Okay, now you say, well, I don't believe in your threads. I don't believe that there are threads sweeping around. This is not a question of belief. It's a question of making an assumption. You have to make an assumption regarding an invisible, intangible entity. In fact, everybody has done to this day, so it must be news to you, but everybody's been using particles for the last 2,000 years. And they say there are particles there. They do everything with particles. They simulate them with particles. Did you ask them if there are really particles forming a magnetic field? I mean, and let's concede. You say there are particles, okay, show me how you attract with those particles. Show me how you repel with those particles. Show me the mechanism if you're going to do it with particles. But everybody has made the assumption that the region called field is filled with particles. And we're saying, no, it's not particles, not discrete particles. We have swinging threads. It's an assumption just like particles, no different than particles. So when you say, Bill, I don't believe in your threads, no problem. Do you believe in particles? And if you believe in particles, where did you get that? Wasn't that an assumption? Or did you see and touch the particles inside a magnetic field? So yeah, you have to make an assumption no matter what. You can't escape the assumption, no matter what. Okay? Okay, so what did this fellow say? The critic, fellow who criticized my videos, he talked about green pixies. He said, well, I can also put green pixies in there. Okay, so I didn't know really what a green pixie was. I mean, who knows what it is? Maybe he's talking about little particles, or maybe who knows what, And so I looked it up and I'm saying, let's see what a green pixie is, okay, officially. Okay, so we look up green pixie and we find this, okay. Here you have these little green pixies on the left that look like leprechauns or, little gnomes. And then you have the green pixies on the right, which are like particles. These are the two things that I found out there. Maybe there are other versions. I mean, I don't know. This fellow would have to specify what he means by a green pixie, but those are the ones that I found. Okay, so I'm gonna simulate his stuff with green pixies. Okay, let's find out if the green pixies that he says that, yeah, he can come up with green pixies. Okay, let's see if we can explain magnetism with green pixies. We'll concede. Let's assume there are green pixies. No problem. Okay, we're looking at mechanisms here. Let's find out if he can do it with green pixies. Okay, here we have one way of doing this. I didn't do it with the green pixies. I replaced them with gingerbread men because I just want to show you the mechanism that you can explain with green pixies. You can explain attraction. And here you see it, okay? We have these green gingerbread men. You can replace them with pixies as you want. I thought it was better to do it with gingerbread men because they're usually, you know, put in series and holding hands and so on. And I said, well, you can explain with this. If you want to replace them with pixies, no problem, okay? So we can explain it with these gingerbread men. We can also do it with angels. You know, they're magical too. You know, here's two angels pushing two magnets, one towards the other. Maybe that's how magnetism is done. Can you understand the mechanism? Of course you can, because you can see the angels pushing the magnets towards each other. Okay, so you say, yeah, I understand the mechanism. Now you say, well, I don't believe in angels. That's irrelevant. We don't care. We're trying to understand the mechanism this guy is proposing. The guy is saying there's angels pushing the magnets together. Or maybe they're pulling them. You know, maybe the angels are on the inside pulling the magnets together. The important thing here is, do you understand the mechanism? That's the important part, okay? And how do you push them apart? Well, again, that's how repulsion works. You know, we can put the angels in between and it works. Okay, we understand the mechanism. We're saying that angels are pushing the magnets apart, and they could also be pulling them apart. Okay, so maybe that's how repulsion works. So we can explain with green pixies, meaning, you know, leprechauns, gnomes, angels, gingerbread men. We can explain attraction and repulsion if we put them in there. Okay, you would understand the mechanism. Okay, so if you put these guys in there, we can explain the mechanism. Do you believe in green pixies? Do you believe in leprechauns? Do you believe in angels and unicorns? We don't care. That's separate. We're trying to understand the mechanism that the guy is explaining. Okay, and it's a little better than the two spinning electrons, the watermelons spinning in two different carts. We don't understand the mechanism there. Here we understand the mechanism. Okay, so you may not like angels, you may not like pixies, but you understand the mechanism. Do you believe it? That's separate. You deal with that in church on Sundays, Sunday school. You know, you talk to your priest about belief. Here we talk about mechanisms. Okay, so let's get that right. We're looking at mechanisms only. We understand the pixie mechanism if the pixies are little green men of some kind, you know, angels or leprechauns or whatever. So we understand it. Let's look at the other one, the little green particles. Okay, if those are the pixies he was referring to. Okay, so here let's see. There you have them. You have the pixies, the green pixies between two magnets. Please explain attraction with your green pixies. How does it attract? How does it repulse? I mean, here I'm putting the pixies in there. I'm not allowing you to put the pixies. What are these? If you say the pixies are a bunch of loose particles, okay, fine. Please explain attraction with your green pixies. See, this is the problem. You cannot explain it with your green pixies if pixies are a bunch of particles. And that's the issue. The issue is you can explain it with angels better than you can with little particles. So no, do not, now, you know, they have this other version, the Casimir effect, where you have particles pushing on the outside if you remove the ones in the inside. Yeah, and then how do you produce repulsion then? You put them back in and push the magnets apart, you know. Who's putting? How do you put them and get out? What's the mechanism for putting particles in, taking particles out between two magnets? I mean, are you saying that somehow the magnet knows that I'm going to remove the particles between and whoop, they stick to each other? But this is very simple, very, very simple. Take two magnets. Don't take my word for it. Just do it at home. Do it on your own, okay? Take two magnets, okay, like I'm doing here. Two simple magnets, okay, so that you get the real basics, okay? And you can see that they're being pulled from the inside. I mean, I hold them and I don't feel any push from the outside. Nothing's pushing on my hands. The tug is from the inside. Okay? So if you're going to do a Casimir effect, then you're obviously an irrational individual, because it's not like you're removing the particles from between the magnets and you have the particles from the outside pushing in. That's not what's happening here. What you feel here is a tug from the inside. It's tugging on the magnets from the inside. That's what it's doing. So there's something here which is pulling on that magnet that you cannot see or touch. Okay? And you may say, well, it's a field. Well, you got to identify what's inside the field. You got to tell me what the field is made out of. What's happening in that field? You saying the field, you haven't said anything. That's like saying it's X in there. Okay, so it's X. What's X? Draw it for me. Show me what it looks like. Okay? And what are you going to draw? A field all by itself? Okay? And again, it's got to be in motion because, both Faraday and Maxwell said there's matter in motion inside a field, whether you like it or not. So if you don't put something in there, you're doing, concepts again. You're doing black magic. Okay, so how do we do it in science? Okay, we don't do it with green pixies. We do it with threads. And here's the mechanism. And hopefully you can understand the mechanism just by watching. You can see what we're proposing. Okay, so here we go. Okay, here's attraction. Okay, if we turn the magnet around sideways, nothing changes. You still have attraction. Only when you turn it up in the north-south direction, and you can see now we went from clockwise to counterclockwise. Now you have repulsion. And here it goes one more time. Okay, that's attraction. Okay, and again attraction. And now you have repulsion as soon as you have clockwise versus counterclockwise on the top, for example. Okay. So that's the mechanism. What we're saying is the threads are moving. That's what a field is. A bunch of threads which are sweeping around in that region we call magnetic field. And you might say, well, you don't believe in threads. And again, we don't care. It's irrelevant. We make an assumption about what's in that region known as field. And we're saying that it's not particles, which is what the official version is. We're saying it's threads that are swinging around. Field is made of threads swinging around, countless threads that are swinging around. And again, we just are interested in you understanding the mechanism. And it's a rational mechanism because you can see how attraction occurs and how repulsion occurs. And here it is one more time. Look at the mechanism. That's all we're interested in. And I use my two little fellows, axle and rod, and you can see how they're swinging their ropes. They're jumping rope. And just look at the direction of the ropes, and it'll give you an idea how a magnet attracts and repels another magnet. The mechanism. Okay, look at the mechanism. Here they are. Okay, both on the top are clockwise. If you turn it sideways, nothing changes. You have counterclockwise, counterclockwise. Only when you turn one around and have clockwise versus counterclockwise do the ropes clash and push each other away on the bottom and on the top. But when you have it in this direction, counterclockwise and counterclockwise at the top, well, they attract. Why? Because the ropes latch into each other. And if you turn it around, nothing changes. So we explain what we observe with two magnets. Okay, very simple, the mechanism. Do you believe in ropes? We don't care if you do or not. Okay, it's irrelevant to the question that we have here. We're trying to figure out how a magnet works. Okay, and what we're saying is a magnet, this is the mechanism of how a magnet works. When they both go in the same direction, okay, on the top and also on the bottom, the two bottom ones go in the same direction, the two top ones go in the same direction, the threads. And so they latch onto each other and they pull. That's what we're saying. And when you turn the magnet around, now they clash. And now they push each other away. So it explains, it simulates what happens to two magnets. And anyone who says opposite is simply just plain hard to get. That's all he's doing. His religion went down the drain, so he doesn't like you saying that, he is an irrational individual. Yeah, we have a mechanism. Whether you believe in that mechanism, we don't care. We're showing you a mechanism of how two magnets work. And you can't do that with your green pixies, meaning the particles. You can do it with angels better than with particles, which is what the establishment uses. It's the establishment which uses green pixies, meaning particles. And they cannot do it with particles, and that's what we've been simulating, all these invisible, intangible phenomena for the last, I'd say, at least 2,500 years. Okay? Okay, but does it stop there? No, we're saying not only can they not explain magnetism, it turns out that, the establishment cannot explain gravity. I mean, we've known about gravity since man had use of his reason. I mean, since, I guess, the Paleolithic. I mean, people notice that if they dropped a stone, I guess the caveman dropped a stone or let go of a stone, it always fell to earth. It never fell to the sky. And a lot of people must have wondered about that throughout history. At some point people say, why does it always fall to the ground? Why does it always fall on my foot, this stone? And of course, they never had an explanation for that. Why? Because they could not see or touch the mediator of gravity. That's the big problem. If you can't see or touch it, then you say, well, I have no explanation. And the explanation is very simple, very, very simple. You just have to make the invisible visible. Once you make it visible, then it's a piece of cake. And again, if I just show you the stone in the earth and let go of the stone and the stone falls to earth, you don't understand the mechanism. But if I make the mediators visible, now you understand the mechanism. Now, whether you believe that those are the mediators Mother Nature uses, that's a separate issue. That's a question of belief. But right now we're trying to explain the mechanism, okay? The why, not the how, but the why, okay? Okay, and what the establishment does, in fact, what this individual who criticized the videos believes in, is that he thinks we have an explanation in space-time. That, the mathematician came up with all these years with space-time, and they say, well, that explains why the Earth doesn't fly out of the solar system. It explains many things, okay? And he said it explains Mercury. In other words, it explains, he said, the orbit of Mercury, meaning that there is no planet Vulcan between Mercury and the sun, which is what people speculated on, that maybe that was the case. And yeah, they solved that problem. There's no planet Vulcan, but it created bigger problems, like I showed the other day, in the fact that it doesn't explain the direction in which the canvases, the fishnets of space-time, point in the case of Oberon, the moon of Uranus, and in the case of Charon, which is the moon of Pluto. In the case of Oberon, you have Oberon going towards the sun. And in the case of Charon, you have this bullseye pattern as seen from the sun. And the Earth, weighs it down together like parallel with the ecliptic. And so these three have different orientations for the fishnets. You cannot explain that with Einstein's theory. Okay, but you got to look at the previous video of pictures worth 1,000 words. Okay, so here we start out on the wrong foot because we have Stephen Hawking, and he was a prominent mathematician, mathematical physicist, as they call him, that recently died. And this is what he has to say about space-time. Okay, he says, an event is something that happens at a particular point in space and at a particular time. It is often helpful to think of the four coordinates of an event as specifying its position in a four-dimensional space called space-time. It is impossible to imagine a four-dimensional space. Well, that's a terrible way to start a presentation. He's going to give us a physical interpretation. He's going to say that objects slide or roll on this fishnet he calls space-time, but he begins by telling you that there's no way that you can even imagine a four-dimensional space. In other words, the thing that he's going to use to create gravity, why the Earth doesn't fly out of the solar system, what physical entity prevents it. He says it's space-time, but I cannot imagine it for you. No one can imagine it. So he's telling you right up front that he's not going to give you a physical interpretation. You say you can't imagine it, but just believe it. Yeah, no kidding. Okay, here's a. You probably look at the night sky if you've got a telescope, and you'll see Andromeda Galaxy. Okay, and it's pretty far away. You got to look for it. Okay, it's not around the corner out there in the night sky. And here's a picture of that. The one on the left is Andromeda. The guy on the right is the Milky Way galaxy. Okay, so there you have them labeled. And so it's pretty far away, okay, the Andromeda galaxy from Earth, right, from our galaxy. And just to give you a sense of the sizes of what you're staring at here, here you have the Andromeda galaxy, and it's 220,000 light years in diameter. So if you go from one edge to the other of this galaxy, it would take you 220,000 years if you travel at the speed of light. Okay? In comparison, just the Earth, which is a little tiny dot, invisible dot in the one on the right in the Milky Way, it takes 0.04 second, 400ths of a second to go at the speed of light from one side of the planet to the other. And here to go through the galaxy, this entire galaxy, 220,000 light years. Big distance. And so what is the distance between our galaxy and the Andromeda galaxy? Well, it's 2.5 million light years away. 2.5 million light years away. So you're talking about enormous distances. And why is that more or less important? Well, we're looking at the light. And under the rope model, we're going to find out that the ropes stretch all the way from here to there. That's going to be the argument, okay? So what does it have to travel? Well, if you travel at the speed of light from here to Andromeda or vice versa, it's 2.5 million years if you travel at the speed of light. Now, Andromeda's coming towards us. That means there's gravity between the Milky Way and Andromeda galaxy, whatever gravity is. Somehow we're pulling on the Andromeda galaxy, or the Andromeda galaxy is pulling on us. And so we're getting closer and closer together. And they say it's gravitational pull. It's very slow compared, for these distances. You're talking about something very, very slow. The speed is 400,000 kilometers per hour, as some people calculated. And that would mean that anywhere between 2 to 3 billion years, that's what it would take for these two galaxies to collide, okay, at the speed that they're going now. And here's a simulation of that, okay? You can see that the two galaxies coming together after 2 to 3 billion years, okay, and forming a bigger galaxy. Here it starts again, okay? This is more or less what they envision would happen in 2 to 3 billion years, okay? They hit it a couple times until they finally form a single galaxy, I guess, a bigger galaxy. Okay, so this is the notion that they have, that our galaxies are coming together, meaning gravity, whatever gravity is, okay, is pulling them together. Action at a distance, they call it. So what is pulling Andromeda to us, or us to Andromeda? If it's pulling, that's one issue. The other issue is, hold it, are you saying that light travels like a little ball or a little wave from there to here? That's why we can see the Andromeda galaxy. It travels 2.5 million years, in other words, at the speed of light. When it reaches our eye, it traveled 2.5 million years without hitting anything, just straight to our eyes. And whenever you talk in terms of what's happening in the universe, you're talking about astronomical quantities. That's the point that I'm trying to make here. Anything is outside our everyday experience. Okay, so keep that in mind. Okay, so how does something attract something else from a distance? Well, I like to point out to Mr. Richard Muller. He's a professor at Berkeley, and this is what he has to say about how atoms pull on atoms. Okay, he says that there's a big mass here, and he shows the Earth. That's big M there, and that's little u that's sitting on the planet. Okay, that's Earth supposedly, the big mass, and you're the little mass. And he says there's this big mass here, and you have you with your little mass here. Every atom on Earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. So let's see, if I'm pulling on every atom of Earth, and every atom of Earth is pulling on me, and here we have the Andromeda galaxy, and every atom in our galaxy is pulling on every atom of the Andromeda galaxy, and the Andromeda galaxy, every atom there is pulling on every atom of the Milky Way. Then we're talking about an elongated entity that's stretching all the way from the Andromeda galaxy all the way to us, and us all the way to the Andromeda galaxy. Every atom there is bound to every atom here, and every atom here is bound to every atom there. And you know, when they talk about entanglement, they say it doesn't matter how far two particles are, one influences the other instantaneously. If this one is rolling clockwise and the other one is rolling counterclockwise, immediately when this one is turned around in the opposite direction, that one instantly turns in the opposite direction. They call it entanglement. And so again, if one atom here is twirling clockwise, it means that the one to which it's entangled in the Andromeda galaxy is turning the opposite way. So they're connected. So far we're talking about connections. We're talking about this atom being connected to that atom. And we're talking about the pull of gravity, and they're saying that that atom is attached, it's bound, it's being pulled by an atom here. How do you pull if you don't have a mediator? How do you pretend to pull? Magic? Are you going to say that it is so, that's it? And so the question is, you have to put a physical object in there. That's the issue. And you can't do it without an object. And so here this is how we explain this attraction, this pull. We're saying that the one atom in the Andromeda galaxy is bound to one atom here in our region. In this case, we can say it's the Earth, which is part of our galaxy. Okay, we're saying they're connected. You say, how can they be connected? You're saying that the rope, which is what we're saying this connection is, that a rope-like mechanism extends uninterruptedly from over there to over here. Yeah, that's exactly what I'm saying. That there is a connection directly from one atom in the Andromeda galaxy to us. And you see, that's impossible. How can that possibly be? Well, let's do it with particles. Let's find out. Here's particles. Are you saying that these particles travel 2.5 million years at the speed of light from there to here? Isn't that awesome? You know, I mean, is this believable? That this little particle travels from here to there and our particle travels from here to there? And then the problem here is also that, yeah, you can maybe explain light with this. Can you explain gravity with this? Can you send particles from the Andromeda galaxy to us or us to them and produce pull, that one atom here pulls on an atom over there? Please explain it. Please explain it with this one-way mechanism of particles going in one direction only. Okay? Now, maybe you don't like particles, maybe you like waves, which is actually the same thing, because those waves that you see there, those are made out of particles. I mean, what is it that is waving? And so, again, it's one-way mechanism. So even if you say, well, these are gravitational waves, okay, so they're waves, they're going in one direction. How does Andromeda pull on us? By sending waves, this abstraction, this transverse wave, in one direction. So this is what you got to explain. You got to explain, okay, so there's your wave. I concede your wave or your particle or whatever. And the question is, if it's sending these waves in one direction, how does that pull on us in their direction? Okay? And yeah, if you want a unified theory, you would have to unify light with gravity. You got the light part, assuming, if we concede, okay, so light is transverse waves, they're going from Andromeda to us. How does that pull on us? How does that produce gravity? Where's the unified theory that you can come up with using this model? That's the issue, okay? And on the other hand, let's do it with a rope. And again, we're just going to show one, just like we showed only one wave here, we're going to show only one rope, okay? And here it is, okay? So we're saying that there is a physical object that looks like a rope, DNA-like rope, and it's connected from one atom there to one atom here, obviously extremely thin, unimaginably thin, okay? But the mechanism is what we're showing here. Here you see light, which is torsion of the rope, and you see gravity, which is, one thing, one atom pulling on another. Okay, so now you can explain both the pull of gravity and the speed of light, okay, or why light is a torsion, okay? So you can explain both light and gravity with this mechanism. You cannot do that with particles, and you cannot do that with transverse waves, okay? So how do they do it in general relativity? How does this fellow explain? Well, he says he's got an explanation. The explanation is space-time. We do it all with space-time. Well, first of all, Hawking already says that space-time is unimaginable. It's a concept. It's four-dimensional. That's why they say it's unimaginable. Okay, but let's concede all that. Let's grant it. No problem. Show me the mechanism. Show me how space-time attracts Andromeda to the Milky Way. Okay, now we're talking a long distance here, okay? Okay, so let's look at it. Let's find out what it looks like. Here's Andromeda Galaxy and us, each one on this fishnet known as space-time, okay, that stretches all the way from over there to over here. Okay, great. Okay, we can say, okay, now we can see why they're attracted to each other, because they both slide along space-time, which is the mechanism that general relativity illustrates for attraction between these two galaxies. Great, so far so good. But we forgot something. Let's first put the fishnets underneath each one of the galaxies. Remember, each galaxy is also pushing space-time locally around themselves. That's why the stars don't fly out. So they have their own fishnets, aside from this fishnet that extends all the way from over there to over here, okay? But we're not done yet. Let's unfocus. Let's take the telescope a little further back so that we can see a bigger picture of the universe, okay? And so here we are gonna look at the two galaxies from afar, okay? We're gonna see a bigger field of view now, so they're smaller, and the stars are getting smaller because we're seeing it from farther away, or unfocused, so to speak, our telescope. Okay, but oh, I guess I made an error here because I forgot something. I gotta put the other galaxies that are in the region now that we're pulling the telescope outwards, so that we see more of the sky, and now we should see more galaxies. Okay. So this is what you would see, something along those lines. But again, I guess I screwed up again because, I should have put out all the fishnets that each one of these has. Each one is pushing the local space-time downwards in its region. Okay, so sorry about that. I screwed up. But it turns out I keep screwing up today. I've got a bigger problem here because now I got to superimpose upon this the universal fishnet. Okay, so not only is each one of these galaxies pushing down on its local fishnet, but on top of that we have the universal fishnet, because all these galaxies, at least in the local group, seem to be coming together. And if general relativity has its way, they explain this by saying there's this enormous fishnet that is pulling everybody sliding along this fishnet coming together. That's how they would explain gravity, okay? But I guess I'm not done yet, because this is just a local group. Now let's look at it on a wider scale, okay? Now we have all these local groups, and they're all falling on this bigger universal fishnet. it's getting pretty complicated here, you know. I mean, Jesus Christ. I really feel sorry for poor old God because he's got to manage all this, you know. We have fishnet on top of fishnet on top of fishnet. We got a bunch of fishnets here. And are they saying this is how gravity works? You know, again, I feel sorry for God. He's got to manage this fishnet universe that we have of relativity. We have the local galaxies. They're falling on their own local fishnet. Then all the fishnets are falling towards other fishnets. And I haven't done, you know, I mean, I can continue this forever. I mean, the universe is pretty big. So are they saying this is how the universe runs? Fishnet on top of fishnet on top of fishnet on top of fishnet? Is this the way gravity runs? Yeah, a little cumbersome. Much easier to say that all atoms are physically interconnected in the universe, and that's clean cut. Not only does it explain light, torsion of light along this DNA-like entity, but it produces the attachment, the binding that we need between atoms. Okay, so we can explain light and gravity, the unified theory, with just by changing the assumptions. We don't have to make assumptions on particles, which is what mathematical physics does. We do it with this entity that we call the rope, electromagnetic rope, that binds any two atoms, and which atoms are made of the same rope. So there's no attachment like, you know, it's not taped with glue or anything, you know. It's like the same thread that forms the rope also forms the atom to which where the rope ends. Okay, so one turns into the other, essentially. Okay, this is the model. Okay, we're saying that's what's happening between two galaxies. No space-time, no bending of space-time, which is a concept, unimaginable concept. We're saying there's a physical object. Okay, it looks like a rope, and it binds any two atoms in the universe. Okay, do you believe in it? Well, we don't care. We don't care because science is not about belief. Science is about making an assumption of what's in the invisible, intangible world of Mother Nature, Father Universe, I guess in this case, and with it explaining gravity, light, magnetism, and all the other invisible, intangible phenomena that we see out there. Okay, so here's the conclusion for today. Okay, the so-called scientific, what we call the mathematical method, inherited from the 17th century, meaning experiments, that's the ingredient they put in there, does not address the questions laymen want answered. Laymen ask and want to understand causes and mechanisms. The mathematical method has no success in explaining invisible, intangible phenomena. Okay, that's the situation today. No mathematician alive today can explain how a magnet attracts another. No mathematician today can explain how gravity works. And again, we're talking about causes and mechanism. What's causing gravity? What's causing magnetism? And by that, I don't mean purpose and reason. I mean, what is the physical cause? Okay, that's what we're asking. The mathematical method doesn't even address the issues or questions that laymen want answered. And you can see with the answers given in Quora for magnetism, at least, that you don't get an answer. You simply do not have an answer. In fact, they'll confess that they do not have an answer. And the reason all invisible mechanisms of mathematicians are irrational is that they simulate every phenomenon with discrete particles and concepts. That's the problem. We have to get rid of the particle hypothesis. There are no discrete particles in the universe, and that's where the error is. If you're going to try to explain gravity or you're going to try to explain magnetism using discrete particles, you're going to have a hard time. And at the end of the story, you would say, well, we don't understand it. Of course you don't. And you're going to understand it even less if you're going to simulate it with concepts like field, energy, or force, or time. So even less you're going to understand it. And that's the situation today. So science is not a process of study or of accumulation of knowledge, or it's not even a process, okay? Science is exclusively rational explanations. You have to explain a mechanism. That's what science is about, and that's the definition we have to have of science, because that's what people ask. That's what they want to understand. That's what they want to know. They want to know how gravity works. They want to know how a magnet attracts another. And we have made no progress in the last 2,500 years since we invented the lodestone. We discovered the lodestone. We have not explained gravity, magnetism since those days. Today they have no answers. And you say, well, it's so difficult, it's impossible, I cannot imagine. It's fantastic. We have two little objects. We call them magnets. That's all. That's the whole system. And you're saying we have two objects, two rocks, and you're saying you cannot? In 2,500 years, you have not been able to explain how this one attracts that one? Well, there can only be one reason for that, and that's that you cannot see or touch what's in between them. And if you say there's nothing there because you cannot see or touch them, then you got the wrong definition, an irrational definition of the word thing, of the word object. If you define it instead, other than see and touch, if you define it as that which has shape, and that you cannot see or touch this shape, and then we can make some progress, because now we say there's something that has shape in there, but we can't see or touch it. And people say, well, how do you know it's got shape if you can't see or touch it? Well, the way we do it in science is you make an assumption, just like you made an assumption with particles. Where did you get the particle? It's an assumption. Did you see the particles? Did you see the particles in there? Somewhere between this is a magnetic field made out of particles. Where did you get that idea? And even if I concede the particles, show me with your particles how you produce attraction. And that's where you die, because you cannot explain attraction, action at a distance, with discrete particles. That's the issue. On the other hand, I showed you two mechanisms there, one for attraction, one for repulsion for the magnets, and it's very simple. One attracts the other when threads, go in the same direction. For example, what am I doing here? Clockwise. I'm going clockwise, so they're both going clockwise, right? So this one comes up and this one comes down, and they latch on and pull. And if you turn one of them around, now they're going, one's counterclockwise, the other one's clockwise, they bang and they push each other away. So the mechanism is there. You can't do that with particles. How are you going to explain magnets with particles? Do it any way you want. Your green pixies. Do it anyway. I'll concede the green pixies. Just do it. Just show me the mechanism. And of course, they'll never figure it out, because you cannot do magnetism with discrete particles. You cannot do gravity with discrete particles. You cannot do electricity with discrete particles, because what are you going to have? Electron bead flowing from atom to atom, which is the way the mathematicians simulated today. So where did they get all these particles? Did they see them? Or did they make an assumption and say, let us assume, right, that there are particles? And then they turn that assumption into a proof, and they just take it for granted that they're dealing with particles everywhere. That's what we have today, and that's what we're challenging. Okay, with that, I'll see you on Wednesday, and maybe I'll cover space by then. We'll see you then. I'll try not to mislead you this time. No, I just came up with that at the last moment. I said, there's too much material really to cover today, and so I'm going to have to skip the space part. I'll do that on Wednesday.